this video is all about the specific case that we're going to see again and again of at least one. All right, this happens all the time, right? Like, I might want to keep my store open if there's a high probability that I get at least one customer coming in. Or the probability that you've had at least one math course before taking this one, or something like that, right? This at least one idea comes up a lot. Do you have at least one pet in your household, right? This is a very common idea that we need to have an easier way of dealing with, because that last one I gave, right, the probably have at least one pet in your household. Well, you could have one, you could have two, you could have three, you could have four. If I were to find that directly, I'd have to find the probability that you have one pet, add that to the probability to have two, right? And add that to the probability to have 3 and 4 and 5 and 6 and 7 and 8 and, you know, up to crazy cat person levels of like 40 cats, like, right? Like, so that's a very tedious calculation, and I'd have to do a lot of them in order to actually find out what the true probability is. But there's a much easier way, and that's by thinking about complements. So let's look at this example here. The probability that someone has 3 children and they're all girls is 1 out of 8, 1/8. What's the probability that out of 3 children, at least one is a boy? Okay, so I said that we should be thinking about complements here. All right, so what's the complement to at least one? Right, well, we're counting something here. We're counting something, remember that. So if I'm counting something, it could be 1, 2, 3, 4, 5, 6, 7, right? All of those are at least one. And something we forget as we're counting stuff, because we don't usually count 0 things, is that there can be 0. Okay, so the only other possible counting number that we could get that's not at least one is 0. So as I look at this, if I'm looking for the probability of getting at least one boy, that's 1 minus the complement of that, which is getting 0 boys. Okay. And if we're looking at 3 children here, and I got 0 boys, what does that actually mean I got in terms of girls? I got 3 of them, right? Which we were just given in the problem is 1/8, and this turns out to be 7/8. Okay? Couldn't have done this problem otherwise without these complements, because I don't know what the probability is of getting 1 boy, 2 boys, and 3 boys. I don't know that, right? I mean, we can look it up, I suppose. But we're not given that information, okay? So that's how I want to handle these kind of problems. Whenever you see at least one, I want you to immediately, intuitively say, wait, no, there was something about a complement there. What's the complement to at least one? 0. And then it becomes a much easier problem. We won't have to deal with it in this class, but in my statistics course, there will be certain situations where it's like we're counting, you know, how many people visit Facebook in a day, right? That can be almost an infinitely large number, right? It can be an absolutely huge number, or it can be almost nobody. And I need to add up thousands and thousands of probabilities, technically, mathematically speaking, infinitely many. And I don't need to do that when I've got this much simpler complement way of doing things. So use this. Whenever you see at least one, know that you should be looking at the complement, which is 0, right? And don't forget to do that 1 minus, right? That's what we need to do whenever we're looking at complements, is do 1 minus. The probability that something happens is 1 minus the probability that it doesn't happen. Okay, that's it.